In this video, I am explaining measures of dispersion. Measure of central tendency that gives a value around which the data is concentrated. Average means it represents the entire mass of data using a single value. That single value is like a representative of the given data. But that measure of central tendency is not enough to have a clear picture of the data. I will give you an example. Suppose there is one class and that particular class has two batches. So batch A and batch B. Now it's a small class of 3 students, let us take. There was a class test for 50 marks and class A 3 students got 10, 30 and 50 marks. Out of 50 they got 10, 30 and 50, these 3 students. And here in the second batch they got 28, 30 and 32. This is 30 and 32. These are the marks of the 3 students of second batch. Now if you take the average of these two classes, the average comes out to be 30 in both cases. So this is measure of central tendency. Average gives you a value which represents the entire mass of the data. This single value now represents the entire mass of the data. Now in both the cases average is same. Here also the class batch A has the test marks average 30 and in this case also the test marks average is 30. Now if I just give you the averages of these two batches, you don't have any clear picture of the given data. Now you have to know how the data points are spread with respect to the mean or the central value. That is important. That means how the data is scattered. In the first case, if 30 is the average like this, here you have 10, this is 20, this 30, 40 and 50. In the first case, 30 is the average here, this one, and first data point is 10 and here it is 50. In the second case, 28, first data point somewhere over here, I'll represent here 28, then 30, then it is 32. See, look at the two set of data now. This is batch A and this is batch B. How the data is scattered with respect to this center value. That is 30 is the mean. With respect to the mean here, the second data points are very close to each other, whereas the spread among the data points is more in the first set of data. So to know this, to know the spread or scatter among the data points with respect to the central value or know the variability, we need this measures of dispersion. The variability in the data is called as dispersion, variability or scatter or spread. That is called as a dispersion. So just a central value of the data is not enough to get a clear picture of the data or to draw any inferences about the data. That much is not enough. We need to find out how the data is scattered or spread with respect to the central value. So that is called as a dispersion. Variability in the data is called as dispersion, and how to find out the dispersion, that is called as measures of dispersion. There are different measures to calculate the dispersion. So this is what the significance of having the concept of dispersion in statistics. Now once you get to know how the data is spread out or how the data is scattered, so then you can get a little more information about the given data. See, for example, in this batch the marks are 10, 30, 50, and in this batch the marks are 28, 30, 32 out of 50. Means here there are average students. So in this batch there are slow learners as well as average students as well as advanced learners. So these kind of inferences you can see if you know how the data is dispersed. If I just give you the average of batch A is 30 and average of batch B is 30, both have same average, then you don't get any picture of how the class performance is. It is just giving you the average value. But when you go with the dispersion, or how the data is scattered or spread, then you will get to know that this class has some slow learner student, this class has a slow learner, one average student, as well as one advanced learner. So that picture you will get when you have the concept of dispersion. So that is the significance of having dispersion or learning dispersion in statistics. Now let us see how to measure dispersion. Now there are two basic kinds of measures of dispersion. One is absolute measure of dispersion and another one is relative measure of dispersion. These are the two types in measures of dispersion. So absolute measure of dispersion, what it gives is, it is to measure variability of given data expressed in same unit. So data here is in same unit. And relative measure is the measure used to compare the variability of two or more set of observation. This is two or more set of observations. So you can remember it like this. It is to single set of observation, and relative measure is to measure or the compare, or to compare the variability of two or more set of observations. We use the relative measure. So under absolute measure, we have four types for measuring dispersion. One is range, then second one is quartile deviation, third one is mean deviation, fourth one is standard deviation, and variance. These are the different measures of dispersion, and these come under absolute measure because these are used to measure the dispersion in a single set of data. Relative measure is used to measure the dispersion when you have two or more set of observations. Let us see these measures one by one. First measure of dispersion is range. It is the simplest measure of dispersion. As per the definition of range, range is the difference between the maximum value and minimum value of the given variable in the distribution. So that is defined as range. You have to first find what is maximum in the given distribution and minimum, then you have to find the difference between the maximum value and minimum value. See, for example, here 60, this is the given data set. Here x maximum equal to 70 and minimum, the smallest value, equal to 12. Therefore range equal to 70 minus 12, which gives you 58. Similarly, the second example, here it is continuous data with the frequency here it is given. This is grouped data. So even if it is grouped data, here you can get the range as minimum value is 0, maximum value is 50. So it is in the interval form. So you have to see the lower limit of the first interval and upper limit of the last interval. So 50 minus 0 gives you 50. So the range is here 50. This is how we calculate the dispersion using range. You can define coefficient of range as x maximum minus x minimum divided by x maximum plus x minimum. This is a unitless quantity because range is a measure having the unit. If you want a just a number with a unitless quantity, so you can use coefficient of range when you don't want the unit. So for example, in this example, the coefficient of range is 58 divided by this maximum value 70, minimum is 12. Add them, you will get 82. So 58 by 82, which is equal to 29 by 41. So this is called as coefficient of range. Next is about quartile deviation. So quartile deviation is defined as QD, I will write, which is equal to Q3 minus Q1 divided by 2, where Q3 is third quartile and Q1 is first quartile. I've already uploaded a video on partition values. There I have explained what are quartiles and how to find out quartiles. So here it is quartile deviation. Quartile deviation is given by Q3 minus Q1 divided by 2. Q3 is the third quartile and Q1 is the first quartile. And if you want coefficient of quartile deviation, then it is equal to Q3 minus Q1 divided by Q3 plus Q1. So this gives you a unitless quantity. So that's why sometimes we need coefficient of quartile deviation as well. See one example. Find quartile deviation for this data. This is a grouped data which is having class intervals. So class interval frequency, you write it down. Then you have to find out the cumulative frequency, 3, add 5 to this, 3, 8, 8 plus 7, 15, 15 plus 9, 24, 24 plus 4, 28. So sum of all frequencies is 28. So we need quartile deviation means it is Q3 minus Q1 divided by 2. So we need Q3 and we need Q1, first quartile and third quartile. How to find the first quartile? You need the first quartile class. To find the first quartile class, you have to find out n by 4, which is 28 by 4. That is equal to 7. So you have to see in the cumulative frequency column where this 7 comes. So that 7 is here. This is up to 3. Okay, this is up to 8 means 7 comes within this cumulative frequency. So the corresponding class is called as a class interval, quartile class or first quartile class. So this is first quartile class. So now you have to substitute in this formula Q1 equal to lower limit of the quartile class 10 plus n by 4, I got it as 7 minus C means cumulative frequency just preceding the quartile class. This is the quartile class. Cumulative frequency before this quartile class is 3 divided by F means frequency of the quartile class, which is 5, into H means width of the quartile class, which is 10. This gives you 10 plus 8, which is equal to 18. So Q1 is 18. Similarly, you have to find out Q3 now. To find Q3, we need 3n by 4. So which is equal to 3 into 28 by 4, which is equal to 21. So 21, you have to see in the cumulative frequency column where this cumulative frequency 21 comes. Up to 15 here, up to 24 here means this is the third quartile class. To apply this formula, first you need to get the quartile class, corresponding quartile class. So Q3 equal to lower limit of the quartile class is 30 plus this value we got it as 3n by 4. We got it as 21 minus cumulative frequency just preceding the third quartile class is 15 divided by frequency of the quartile class is 9 into width of the quartile class 30 to 40 means it is 10. So when you simplify all this, you will get the value 36.67. So if you want the detailed explanation, I have already uploaded a video on partition values. Please watch that video. Now we want the quartile deviation, which is equal to Q3 minus Q1 divided by 2. So 36.67 minus 18 divided by 2. This finally gives you the value 9.335. So this is how we calculate quartile deviation. Just you have to remember the formula Q3 minus Q1 by 2. So based on whether the data is grouped or ungrouped with the frequency, without frequency, based on that you have to find out the corresponding quartiles Q3 and Q1. Now next measure of dispersion is mean deviation. Mean deviation means it is average of the sum of the absolute values of deviations from any arbitrary value. That arbitrary value can be mean, median or mode. So this deviation is least when it is calculated from median. So always it is often suggested to calculate it from median because it is least when it is calculated from median. So this is the formula, mean deviation equal to, it is average of sum of the absolute values. Absolute value is denoted like this. You have to find out the deviation of each observation from this arbitrary value. Then you have to take the sum of all those deviations. Then you have to take the average of, then you have to divide it by n. So that gives you mean deviation. If A is mean, then the formula becomes about mean means mean deviation about mean. You can write like this, which is 1 by n into summation I equal to 1 to n modulus of xi minus x bar. So if it is about median, then 1 by n into summation I equal to 1 to n modulus of xi minus m median, like this. So what arbitrary value you have chosen, based on that the formula changes. This is the general formula. That too, it is for ungrouped data. If you have grouped data, then in that case mean deviation is given by 1 by capital N, means sum of all frequencies, summation I equal to 1 to n fi into modulus of xi minus a. So you have to multiply it with the frequencies. This is for grouped data and this is for ungrouped data. Let us see few examples now. You have to find mean deviation for this given data. 1, 2, 3, 4, 5, 6, 7. So I'm going to find mean deviation about mean. Nothing is specified here. I'll find it out about mean first. So for that we will find out x bar. X bar is nothing but mean. So it is ungrouped data. So 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 divided by 7. So this gives you 28 by 7, that is equal to 4. So mean is 4. You have to find out deviations now. So write the values, data values, then xi minus x bar, 1 minus 4 minus 3. Then 2 minus 4 minus 2, 3 minus 4. This is, you have to take its difference from this mean. 3 minus 4 minus 1, 4 minus 4 0, 5 minus 4 1, 6 minus 4 2, then 7 minus 4 3. Next we need absolute values. All values must be positive. So 3, 2, 1, 0, 1, 2, 3. Add all these values. That is, this gives you sum is equal to 12. Therefore, now we want mean deviation. Mean deviation equal to sum of all these absolute values 12 divided by total number of observations 7. So that gives you the value approximately 1.71. So this is the dispersion about mean, how the data points are scattered with respect to the mean. The dispersion is at a level of 1.71. Now see here, second problem, find mean deviation from mean for this given data. So this data is ungrouped data itself, but it is with the frequencies, ungrouped data with the frequencies. Therefore, we have to use the another formula which we have written for grouped data. That formula only we have to use. So mean deviation equal to summation of fi into modulus of xi minus x bar divided by capital N. This formula itself we have to use because frequency is given. So first let us write the table xf. So we need here 1, 2, 3, 4, 5, 6, 7. Then the values frequency 3, 5, 8, 12, 10, 7, 5. Now next we want here from mean. Okay, we have to find it from mean. Therefore, first we have to find mean. Mean for the data with the frequencies. So, how to get the mean? Summation of fi into xi divided by capital N. First, let us find capital N, sum of all frequencies. So, when you add all these, you will get the value 50. Next column should be fi into xi. Okay, fi into xi means each data value you have to multiply with the frequency. 3. 2 5s are 10, 24, 48, 50, 42, 35. Now add all these values, then you will get this sum as 212. Now let us find out the mean, that is 212 divided by 50. So this gives you the answer 4.24. This is 4.24 x bar. Now we have to find out the deviation of every data point from this mean, that is xi minus x bar. Later we have to take its modulus, or else in the single step only you can take its modulus. That means though you get the negative value, you write it as positive. So 1 minus 4.2, that gives you minus 3.24, but I'll directly write 3.24. Similar, 2 minus 4.24, 2.24. This is point here. Next, 3 minus 4.24, 1.24. Then 4 minus 4.24, 0.24. 5 minus 4.24. Here you will get 0.76. Next, 6 minus 4.24, you will get 1.76. Next is 7 minus 4 that gives you 2.76. When you take the sum of all these, which is not required, next is Fy into modulus of xi minus x bar. So you have to multiply frequency with this value, 3 into 3.24, that gives you 9.72. Next, similarly 11.20, then 9.92, then 2.88, then 7.60, then 12.32, and 13.80. When you take the sum of all this, this gives you 67.44. Now you have to substitute here mean deviation in this formula. Mean deviation about mean, which is equal to this sum, we got it as 67.44 divided by total frequency is equal to 50. This gives you 1.348. So this is the amount by which the data is dispersed or scattered about the mean. See the next problem. Find the mean deviation about median. Here they have specified it is with respect to median. So this is grouped data. So write class intervals. Next you have to write frequency. Frequency 3, 5, 7, 9, 4. Next we want midpoint of this class interval, that gives you the value of xi. So it is 5, 15, 25, 35, 45. Next we want cumulative frequency. Cumulative frequency 3, 3 plus 5, 8, 8 plus 7, 15, 15 plus 9, this is 15, 24, 24 plus 4, 28. So capital N equal to 28. So what is the formula for mean deviation about median? So which is equal to summation of Fy into modulus of xi minus m divided by capital N. So we need median. Median is nothing but the second quartile, Q2. How to find out median? L plus in by 4 minus c by f into h. Here it is in by 4 means n by 2 you will get. So n by 2, second quartile is called as median. So n by 2 is 28 by 2, which is equal to 14. So now you have to check the cumulative frequency column where 14 comes. So up to 8 this, up to 15 it is this, therefore 20 to 30. This is the median class. So this is median class. Now use the formula m equal to lower limit of median class is 20 plus this 2n by 4, which is nothing but n by 2, we got it as 14, minus cumulative frequency just preceding the median class, which is 8 divided by frequency of the median class is 7 into width of the median class is 10. So when you simplify all this, you will get the median as 28.57. 28.57. Now we need one more column, that is for xi minus x. So I will write here, this gives you xi minus m. One more column for xi minus n. Then Fy into modulus of, I'll erase this. So this is the formula. Then we need xi fi into modulus of xi minus m. So xi minus m means from each midpoint you have to subtract median. So median value we got it as 28.57. So 5 minus 28.57. Though you get negative, make it as positive. So this gives you 23.57. Then next is 15 minus 28.57, which gives you 13.57. Then 25 minus 28.57, that gives you 3.57. Next 35 minus 28.57, that gives you 6.43. Next 45 minus 28.57, which gives you the value 16.43. Now you have to multiply this with the frequency. So 23.57 into 3 gives you 70.71. Next 13.57 into 15, which gives you 203. 13.57 into 5, which gives you 67.85. So next continue like this. This gives you 24.99. Then this is 57.87. Then 65.72. So I need the sum of this column. I'll write here that sum equal to, you will get 287.14. Now you have to substitute in the formula for mean deviation. 287.14 divided by total frequency is 28. So this gives you the value around 10.255. So this is how the data is scattered about the median. You can find out the mean deviation about mean also for the same data. Then you can check which is the best method. So this is how we calculate mean deviation for the given data. Now about the last measure of dispersion, that is variance and standard deviation. So in previous methods, we have seen that while calculating the mean deviation, the negative deviations are straight away made positive using modulus. To overcome this drawback, we can use the next measure of dispersion, which is variance. Here what we do is we directly calculate the square, because square of any number, whether it is positive or negative, it is always positive. So variance is the average of the square of deviations of the values taken from the mean. It is taken always from the mean. That is called as variance. See, average means sum of all these deviations taken from the mean and its square here divided by n. This is without frequencies. With the frequencies, fi into xi minus x bar whole square divided by capital N. This is the formula. Now calculate the variance for this data. So x is 1, 2, 3, 4, 5, 6, 7. Then we need the mean. Mean is x bar equal to sum of all these observations divided by number of observations, 28 by 7, which is equal to 4. So now I need xi minus x bar. So that is 1 minus 4 minus 3, 2 minus 4 minus 2, 3 minus 4 minus 1, 4 minus 4, 0, 1, 2, 3. Now I need xi minus x bar whole square, which gives you 9, 4, 1. Square this, 0 square 0, 1 square 1, 2 square 4, 3 square 9. I need the sum of all these. Sum of all these is 28. So therefore, variance sigma square equal to 28. Variance is denoted by sigma square, 28 divided by the total number of observations, 7, that is equal to 4. So this is how to find out the variance, which gives you the dispersion of the data. See, there is one more formula to find the variance. Sigma square equal to summation of xi square divided by n, I equal to 1 to n, minus summation of xi by n whole square. This is nothing but the mean. So we have summation I equal to 1 to n xi square by n minus x bar whole square. So This method also can also be used to find the variance, because once the mean is found, you just have to find out xi square. See, xi square, if I write here, so 1 square 1, 2 square 4, 9, then 16, 5 square 25, 6 square 36, and 49. Then I need the sum of all these. So this sum is 140. Then you have to substitute in this formula. Sigma square equal to 140 divided by n is 7 minus I got x bar whole square. It is 4 square. So this gives you 20 minus 16, that is equal to 4. So in this case also you will get sigma square equal to 4. So this is also comparatively easier method, because here you have to make a column for negative values, then you have to take the square. Instead of that, taking xi square, then mean already it is found, you have to take the square of mean. You have to subtract that square of mean from this value to get the variance. Now see one more problem. Here this is a grouped data. You have to find the variance of this data. Class, frequency. Class is 0 to 10, 10 to 20, 20 to 30, 30 to 40, and 40 to 50. Then frequencies 3, 5, 7, 9, 4. Then either you can use this formula or else the first one. So if it is for frequency, then you have this formula, summation of fy xi square divided by n minus then mean square x bar whole square. Just you have fy into xi square tau. So you have to find out xi first, midpoint 5, 15, 25, 35, 45. Okay, then I need xi square. If I am using this formula, then I need xi square. Xi square is calculated 25, then this is 225, then this is 625, 1225, then it is 2025 xi square. Next I want fy into xi square. Even before that you need to get the mean. Mean is x bar equal summation of fy xi divided by capital N. So here also this is capital N, sum of all frequencies. So here capital N, this value equal to 28. So this is equal to, I need fy xi square as well as fy into xi. Fy xi is this, 3 5s are 15, 15 5s are 75, 25 7s are 175, 35 9s are 315, then 45 4s are 180. This is fy xi. Then I need fy xi square. This 25 3s are 75. Then 225 5s are 1125. Then 625 7s are 4375. Then I have 1225 9s are 11,025. Then 2025 fours, 2025 fours are 8,100. So I need this sum, I need this sum now. So this sum is 24,700 and this column sum is 760. So we have to substitute here to get the mean. 760 divided by 28 gives you 27.14. Then sigma square, use this formula. This is the formula for the variance. Substitute this value. 24,700 divided by 28 gives you 882.14 minus x bar square. Mean is 27.14 square. So when you simplify this, you will get the final answer as 145.56. So this problem can be solved using the formula sigma square equal to summation of fy into xi minus x bar whole square divided by capital N, I equal to 1 to n. This formula is also can also be used to solve the problem. Here I have used the second formula. Now let us see what is the standard deviation. Standard deviation, it is very important measure of dispersion. So this gives you positive square root of variance. Variance is denoted as sigma square and standard deviation is denoted as sigma. Standard deviation is the positive square root of variance. Whatever formula you have for variance, that in that formula only you have to take a square root on both sides, then you will get sigma equal to square root of summation I equal to 1 to n xi minus x bar whole square divided by n. This is without frequencies, and this is the formula for standard deviation with the frequencies. See here, so in this formula only, sigma square equal to 4, sigma square equal to 4, this implies sigma equal to 2. Square root of 4 is 2. Here the standard deviation is 2. So standard deviation is used to compare. Variance is using variance only, standard deviation is calculated. To calculate standard deviation, first you need variance, then you have to take the square root of that variance to get the standard deviation. See here, standard deviation equal to 2. Now in the second case, sigma equal to, in case if it is asked to find the standard deviation, first you find the variance, then only you find the standard deviation just by taking the square root of that variance. See here in this case, if you take square root of 145.56, you will get 12.06. This is the standard deviation. Now this standard deviation can be used to compare the dispersion in different methods. See here, in this case, using this quartile deviation or mean deviation, using the mean deviation for the same data, we got the dispersion as 10.255, whereas using the standard deviation, we got the dispersion as 12.06. Almost equal, close. So standard deviation is the best measure of dispersion compared to the other measures. See here in the case of quartile deviation, we got the deviation around 9.335. So the dispersion is getting increased when you go with the better methods. Here it was 9.33. In the case of mean deviation, it was 10 point around. In the case of standard deviation, it was 12 point. So similarly for this ungrouped data, like see for this ungrouped data, I got mean deviation as 1.71. Then so here standard deviation as 2, sigma equal to 2. There it was 1.71. So dispersion, this gives you a quite precise value for the dispersion standard deviation method. So to calculate the standard deviation, you need not do something new. First get the variance using the formula of variance, then get the square root of the variance. That gives you standard deviation. This is just to have an idea about what is root mean square deviation, RMSD. Root mean square deviation is nothing but it is the deviation which is taken from assumed mean, xi minus, here you have xi minus a whole square. So a means, so here a means the assumed mean. If assumed mean equal to the mean x bar, then it becomes standard deviation. The same formula reduces to standard deviation. Just to have a knowledge of what is root mean square deviation, here deviations are taken from the assumed mean. So assumed mean, if it is equal to the mean, then it is called a standard deviation. Assumed mean, you know how to take the assumed mean. We have done in all our previous methods, and in the very beginning where I have explained the measures of central tendency, there we have talked about what is assumed mean. So if the deviations are taken from assumed mean, then we call that as root mean square deviation. Rest all same, formula is same, square root of this root, then mean, then square, and these are the deviation. The name itself says. Now let us see how to find the variance of combined series. Suppose n1, n2, so on up to nk are sizes of the given two series. Of each series, x1 bar, x2 bar, so on up to xk bar are the means, and sigma 1 square, sigma 2 square, so on up to sigma k square are variance of k populations. K populations given, and this is the size of the population, this is the mean of the population, and this is a variance. Then the combined variance is calculated. Sigma square is combined variance, which is equal to 1 by n1 plus n2 plus so on up to plus nk into n1 into sigma 1 square plus d1 square plus n2 into sigma 2 square plus d2 square plus so on up to nk into sigma k square plus dk square. where di is xi bar minus x bar, where x bar is the combined mean. So combined mean is calculated like this: I summation I equal to 1 to k ni into xi bar divided by summation I equal to 1 to k ni, sum of the sizes of all the k populations, and here it is ni into xi bar. Xi bar is the individual mean of the populations. You have to take this sum, divide it by this, that gives you the combined mean. So deviations are nothing but the difference of each mean from this combined mean, that is di. So d1 means x1 bar minus x bar, d2 means x2 bar minus x bar, like that. So this is the formula to find out the variance of combined series. One example: suppose a series of 100 observations has mean 50. So n1, first series size is 100, has mean x1 bar equal to 50 and variance sigma 1 square equal to 20. Another series of 200 observations, so n2 equal to 200, has mean 80, x2 bar equal to 80 and variance sigma 2 square equal to 40. What is the combined variance of given series? So combined variance sigma square equal to 1 by n1 plus n2 into n1 into sigma 1 square plus d1 square plus n2 into sigma 2 square plus d2 square. This is the formula of combined variance. So this equal to 1 by 100 plus 200, which is 300, into n1 is 100 into, we need sigma 1 square, that is 20 here, 20 plus d1 square we want. So first let us find out what is the combined mean. X bar equal to summation I equal to 1 to 2, here only two values you have to take, ni into xi bar whole divided by summation I equal to 1 to 2 ni. So here you have to find out n1 into x1 plus n2 into x2. You can, if you want, you write like this: n1 x1 plus n2 x2 bar, okay, whole divided by n1 plus n2. So n1 x1 bar 100 into 50, that is 5000, plus n2 is 200 into x2 bar 80, plus 16,000 divided by n1 plus n2, it is 300. So this gives you 21,000 divided by 300. So two zeros will cancel, so which is equal to 70. Now we need here d1 and d2. d1 is x1 bar minus x bar, d2 is x2 bar minus x bar. The combined mean is 70. So x1 bar is 50 minus 70, which is equal to minus 20, and d2 equal to d2 is x2 bar, which is 80 minus 70, that is equal to 10. So here I have to substitute 1 by n1 plus n2 is 100 plus 200, which is 300. n1 is 100 into sigma 1 square is 20 plus d1 is minus 20. d1 square is minus 20 whole square, which is 20 square 400, plus n2 is 200 into sigma 2 square. Sigma 2 is square is 40. So 40 plus d2 is 10. d2 square is 10 square 100. So this is 100. So I have to simplify this. I'll write here 1 by 300 into, here it is 42000 plus this is 140 28 000. 42,000 plus 28,000 divided by 300. So this finally gives you the answer 233.33. So this is sigma square variance of the combined series. This is how we calculate the variance of combined series. When there are more than one series given, then this is the formula to calculate the variance of combined series. To get the variance of combined series, we need first the combined mean, then the deviation of each mean from the combined mean, then substitute in this formula. Now about coefficient of variation, which is also called as CV, coefficient of variation. This is a relative measure of variability. if we are comparing the two different data series, then we use coefficient of variation. That is, to compare two series, we need CV. CV is given by the formula sigma by x bar into 100. Sigma is the standard deviation, x bar is the mean. If a data series has a smaller CV, then that series is more consistent than the other. Data series with the higher CV is less consistent. But see here one example. Suppose you have a data series with these data points 10, 10, 10, and another data series with 3 data points 50, 50, and 50. These are the two series. We have to compare these two series now. Now the mean of the first series is 10 and the mean of the second series is 50. Now standard deviation here, sigma 1 is 0, standard deviation here also it is 0 because there is no deviation from the mean. They are concentrated at the center value itself. Here also 10, mean is also 10, the values are also 10. No dispersion, no scattering. The data is not spread. In this case also the data is not spread. So you will get standard deviation 0 in both the cases. So in that case what happens to your CV? CV becomes 0. In this case also CV becomes 0. But see here, before drawing the conclusion here, you have to check the mean of each series. The second series is having higher mean, so second series is more consistent than the first. Higher mean means it is in the denominator. What happens to the CV value? So if this is more, this will be less. Less CV means the more consistent. Therefore, highest mean gives you more consistent series. Smaller CV, more consistent. Highest mean is the series with highest mean is more consistent. This is in the case if the standard deviation comes out to be 0, hence the CV comes out to be 0. So in that case you have to check with the mean. Means different, higher mean will give you the more consistent series. Let us see example. If n equal to 10, x bar equal to 4, sigma x square equal to 200, you have to find CV. CV equal to sigma by x bar into 100. X bar is given, which is 4. We need sigma. Sigma equal to square root of summation of xi square by n minus x bar whole square. So this is using the another formula of variance. Summation of xi square given square root of 200 divided by 10. 200 by 10 minus mean square 4 square, which is 16. So this gives you 20 minus 16 square root of 4, which is nothing but 2. So standard deviation is 2. 2 divided by x bar is 4 into 100. So this gives you 1 by 2 here, 100 by 2, that is equal to 50. Coefficient of variation of this data is equal to 50. Here not comparing, we are finding using the formula, we are finding what is the coefficient of variation. Second problem, suppose batsman A has mean 50 with standard deviation 10. Sigma 1 equal to 10, mean x1 equal to 50. And batsman B has mean 30, so x2 bar equal to 30 with the standard deviation sigma 2 equal to 3. What do you infer about their performance? Performance more consistent. The series is most consistent for smaller CV. If I have written here, smaller CV means more consistent. So CV of the first series is sigma 1 by x1 bar into 100. So that gives you 10 by 50 into 100. So 0 cancels here. 5 ones are 5 twos are. This gives you 20. So CV of second series is sigma 2 3 by 30 into 100. So this gives you 10. CV of the batsman 2. This is coefficient of variation of batsman A and coefficient of variation of batsman B. So which batsman coefficient of variation is less? The second, batsman B has less coefficient of variation. Therefore, the performance of batsman B is more consistent than batsman A. That is the conclusion you can draw. So batsman B is more consistent than batsman A. Now here you don't go for looking at the mean. If the standard deviation is 0, then only you have to check the mean. Otherwise you have to go with the coefficient of variation formula.